Så, tack så mycket Kristina för introduktionen. Jag är väldigt glad att vara här idag. Det har varit en lång resa. Men jag kommer ha mitt föredrag på engelska eftersom det är väldigt många av studenterna som kommer och folk i min grupp som inte förstår så bra svenska än. Min presentation kommer att vara lite grann en översikt över ett ämne som heter bioinformatik. So now I will change to English. So bioinformatics is a relatively new subject. It's multidisciplinary, but it's coming to maturity. What is interesting with this is that it's not only changing the way that we work in academia, but is getting into our homes in a way that we don't even notice. The thing is that we are living in very exciting times. When the IT revolution was coming, I was a very young PhD student, and the use of computers was not very popular, not even encouraged by our supervisors. Stop playing with that and go back to your cells and cultivate more to get more results. That was kind of comments we got. At the same time that this was going on, the personal computers were coming, IT and internet were there, and this was globalized. This has changed in our ways of living in ways that we could not dream about. Everyone could be today a millionaire, like Zuckerberg or like Sandström or like Bill Gates. But not many people could see this coming when the things were happening. Today, as we speak, we are in a genetic revolution, a biotechnology era. We can do complete genomes in very short time, very low prices. We can examine the DNA, the proteins, the contents of everything that's alive without even knowing how they look like, or even with the need of isolating them. We are coming to the personal genomics era in which you can do your exams and you can decide which kind of medicines you need by your background, genetic background. Nowadays, we are going to see, and this is coming very fast, what we call the home revolution. Everyone has internet. 10 years ago, it was not that easy. You were using modems, or you were using low speed. You could not look at movies. Nowadays, you look at movies, you do the banks, you do everything through internet. The mobile phones, well, mobile phones, you can sit in any train, bus, or any place, and you cannot see anyone communicating to each other. They're all looking at the phones. When I teach nowadays, half of the class is looking at the phones at the same time. I'm not getting angry because most of them are Googling to see if what I'm talking about is real or is wrong, so they can make good questions. So I encourage that. We have the Internet of Things. Most of you don't know what Internet of Things is. But Internet of Things is all these devices that are connected to Internet that make our lives like they are today. It's millions of cameras. It's millions of devices that are measuring the way that the temperature is in a house. It's also the refrigerators, it's your TV, everything connected to internet. These are millions and millions of devices. The biggest hacking systems that make many governments' sites to go down was done because most of these devices are in the homes of people, and they had never ever realized that it's a computer behind, and they had never changed the password of those devices. So when you go home, try to see how many of those you have and if you have changed the device. Otherwise, maybe you have visitors looking at everything you are doing and maybe reading everything you are writing. But this is what it is. Another thing that is developing is artificial intelligence and genomics. And let's see what is there. So society is changing. The question is, are we prepared? As I told before, internet revolution. In the 90s, very few that have that, most academia. Today, everyone in the world is using it. But not many people knows how it works, even if you use it. You have no idea where routers are, IP numbers, how to change that. How do you communicate from one computer to the other? Most people think that they're anonymous. No one is anonymous. I'm very surprised when they're discussing that Facebook is selling information. I mean, everyone should know that that is happening anyway. Not only that, Google and every kind of service you use on internet is for selling. That's where they do the money from. Surprise, governments, to me, are naive. Today is even changing politics. Nowadays, all the politicians go and read Facebook and Google and Twitter before they go to job, because they want to see if a scandal is coming, or who they are going to fire today, or what kind of statements that they will do during the day. This is crazy. No long-term politics anymore, just acting in panic. But we're not talking about that today. We're talking about the biotechnology revolution. And in there, I can just start by saying things that have happened. In the 90s, it was decided to do the human genome. Why? Because there was a lot of money there, and there was a competition still during what the Cold War was living after. And the governments in the West wanted to have something that is as exciting as putting the man in the moon. And they asked the communities, what is as exciting as putting the man in the moon? And people say, well, you know, the human genome. And people said, that is impossible. At that time, I was doing one gene, 1,400 base pairs. It took me 1 year to do that. And they wanted to do the human genome, that is 3,000 million base pairs. We were doing things manually when they decided to do this. Make the story short, they started, it took 10 years, it cost 3,000 million US dollars. It was finished in the year 2000. Today, we can do human genomes in less than $1,000. This was a mantra, it was a promise 1, 2, 3 years ago. Today is reality. I will show you why. Today, you don't see publications that don't sequence several hundreds or thousands of genomes if they want to be published. It's becoming very scary for most of us. Most mammalians and many plants' genomes are sequenced, even fossils, bones, the Neanderthal, the new discovered Denisovian. I don't know how many new kind of humans that have disappeared we are going to discover if we just have the bones. This is changing the way that we see history. We are now changing even the way that we see the history of Sweden by just looking at the graves and looking at what kind of background, genetic background, the people buried there. And you can read this even in popular books today, which is really exciting. Millions of bacteria are there waiting for us to be discovered. 99% of all the bacteria cannot be cultivated because we do not know the conditions how they can be cultivated. We only know a few thousand bacteria, and that's what we have in the databases, and that's what we are working with. But there are millions of them there. All of them have genes and systems that we can use. Can you imagine that you can find bacteria living and having a good life in cooking waters, 100 degrees? They have no problems. You can find bacteria in rivers that are coming from the mountains that are 1 or 2 pH. That means sulfuric acid. And they are forming colonies. You see them growing there in beautiful colors. Everything is there to be discovered, waiting for us. So we need more research and more students. We have a lot of challenges. Today, humanity is facing the climate change, the overpopulation, zoonotic diseases, antibiotic resistance, lack of water for agriculture. I can mention only one example where bioinformatics has been really successful, and that shows you that there are a lot of things to do that are really fascinating today using these technologies. So, for example, you may know that most diseases that disappear are back, and they are resistant. We cannot cure them anymore because we misused antibiotics. And people say, how can we misuse antibiotics? But it's very simple. We got antibiotics from nature. It was a defense from one organism to another. Of course, during the millions of years of evolution, the organisms that are being attacked by the antibiotics already have developed a defense against this. So, it was just a matter of time that this will happen. What is happening today is that the pharmaceutical industry, I've been working for 50 years, spent billions of dollars, and they have how many new antibiotics? 1, 2, 3, maybe? Today, you can just go out in your own lab. This is a proof of concept. Take everything that's there, isolate the DNA of everything that's alive. You don't even know what it is. And using bioinformatics methodologies, that means scanning the genes there, they found out around 40 new antibiotics candidates. Of course, because nature is fighting against each other. So it's just to continue doing this. And we are going to have a lot of new discoveries. Is this science fiction? I would say personal experience, because I'm a researcher, I'm curious. Whatever I see, I try to do it, repeat it. Not maybe jump from a big building, but other things. Today it's possible to do your own genetic background. It's very simple. You just go to internet and you select which site and you pay. And it's funny, it's becoming like a market. They offer different prices. Depending the day you go, they offer you one price or the other or more services. I started with this service. It's called 23andMe. And I send my payment. I got a box. I spit on a tube. I send it back. And after a few weeks, I got my results on the internet. And my results were, of course, I have a lot of Neanderthal. Most people say you don't need to pay to tell. But I also got to know, which is also, for everyone knows me, that I drink a lot of coffee, more than average. But what is really fun for me, because I didn't know, it was stories about my family, the background and all that. Well, I know now that I'm 64, 60-something European, and then I have Asian blood and everything. So everything is there, and you can look in detail. This is funny. For many people, they're surprised. They discover that they have some backgrounds that they didn't guess. It's interesting to do. It's very cheap. But the problem is that the human genome is having only 1% of the whole genetic material that is coding for genes. Only 1%. The rest is where the mechanisms that put the genes on and off tells how much, how less. Many diseases are not due to mutations in the genes, but due changes in the regulatory system. And all this, what is the 99% that we do not know very much about. Every year there is a revolutionary paper telling you that they discover a new way of regulating, a new way of taking care of the genetic materials. So it's not good enough only to have, as 23andMe do, they only read the genes and they tell you which variants you have. For that reason, of course, nowadays companies are offering whole genome sequencing. That means they read the 100% of your genome. The price, you remember I told you it was $3,000 million, and I told you that now they were aiming to $1,000. Well, I did it, and I pay only 399 euros. That is half of the price that was the dream for a few years ago, only 2 years ago. So I did it, and of course, and I sent it, and I got my results. And with that results, I get all the raw material. That means I can, as a bioinformatician, I can put all of this in my own pipelines and see if they're right or wrong. But also, they connect all my variants of my genome to known diseases and articles that are connected to why they say that this is like that. So you can really look at the details and not trust everything. What is really nice here, and very related to today's talk, is that I have a very high risk to getting knee arthrosis. So I can be a patient or a subject for the studies that will be developed here. I don't know. But I put it there because of today's talk. And as you can see here, you can see very detailed what my variant is, which ones are connected to risk, and what is my genetic background. This for the price that I told you before. So it's not only for humans. I was talking about these things some years ago, and people told me, yeah, but you know, veterinarians will never use this, and why should they learn about these things? Well, because nowadays you will get, as in the human side, a lot of patients asking you for dedicated exams and taking samples because they got a genetic information that their dog have this or that connection to a disease. So this is what is happening, and we really need to start working and changing from, I would say, more manual analog ways to work to more computing ways of working. And this, it sounds like, well, but we all use computers. Yes, but we use computers only for writing emails and reading the web. We need to use the computers for more advanced things. And those things are, companies are doing this. That's interesting. But what about what I promised in my title about our labs here or our homes? Well, this is changing, and as you can see, even people in the media are getting knowledge about this. This was taking, I took my Just TV on the news in one morning, and they're talking about who and what service you use on the internet, and are they reliable or not? And people want to know this. And of course, everyone at the university needs to know some answers, because they will ask us about these things, the public. So is it enough to know about the human genome? Well, that's the problem. The human genome is only a part of the whole story, because the human genome contains 23,000 genes. But all the bacteria and other living organisms that live inside us, around us, the latest discovery is that there are at least 3 million different genes in those organisms. And they're living with us, defending us, taking care of us. When we do not do that, we get sick, because the bad guys get and take over. This is something we need to understand, because we are what we eat. Is even a lot of research that's showing that what we have as a content and the balance that we have in our microbiome is affecting the way we think and the way we feel. People with depression, even people with allergies, got well when they had worms in their stomach. You can read about these things, but this is really revolutionary things that we are discovering. So, what are the technical revolutions that we are talking about? Will people test themselves and the environment? Because when I say environment, is what you eat. How is your home? Is your home making you sick or not? Maybe you have to take samples. Today you go to the hospital, they take a few samples and say, you have nothing. What they mean is, we have not detected anything. Because maybe you have something, a disbalance or a pathogen, but they have not discovered this. So the question is, can we do better? Well, you remember the mobile phones? We do not know very much about how they work, but we are all using them. The same is coming to us. We have nowadays devices that can sequence very, very long sequences, up to 50,000 base pairs. This was not possible to do a few years ago. That are USB size, that you just connect to your computer, and you can run a lot of genetic sequencing for samples from saliva, blood, whatever you want. You isolate the DNA, you run this. This, we are working in our group to develop some mobile clinics in both in Europe and in Africa. We have a EU project doing this. Nowadays, there is even a new device that you don't even need to prepare things that have a very dedicated or advanced lab to prepare the samples to be run in the sequencer. These machines are coming. You just put your DNA there, and this will prepare things. We'll go to this one, and then you will have dedicated, the dedicated postdocs or PhD students that will tell you how to work with these things. This is a demonstration that we had on the open day as our faculty, and what we have here is actual the sequencer, and here we have two computers that are doing the analysis, and unfortunately we cannot see it, but here is a monitor where you can see things. So this is very portable, is very doable, and is coming to us. Of course, things will get very complicated, because how are we going to educate people in the speed that we need? Because these devices are coming. I can tell you that already a lot of people is buying them because it's possible, it's very cheap, 10,000 crowns. They are using it, they are producing a lot of data, but they're getting a lot of data. That means terabytes of data. What to do then? You need to have some preparation and some a background, and it's there where we are coming. So this discipline will have a role of educating and I would say putting more and more in the hands of the researchers. Why? Because things are going fast. I don't know if this will be reality in 1 or 2 or 3 years, but already the same company that is creating the USB devices is creating one that you can connect to your phone. And when this is coming, maybe new products will come there. It's only imagination that's putting the limits. Maybe you are going to test your food. Maybe you are going to test your microbiome. Maybe you want to see what is the best composition today, tomorrow, next week for what you are eating and the connections with your microbiome. All this is just opening. Maybe you're going to have your whole genome in there. And why I say this, because with 399 euros, you can do your whole genome. This is cheaper than doing many other tests in the hospital. You are going to have this in your telephone. And a lot of people will create things. Maybe Facebook. You're laughing. But maybe Facebook will create a system in which you go to a pub, you go to the disco, and it will start beeping when you have a person that has a very good complementary set of DNA. You laugh, but do you know who created 23andMe, the first company that was offering the scanning of your genome? Google. How many people have sent samples to them? 10 million, including many of us here. They have the biggest biobank on earth. There is no other biobank on earth that have that amount of data. And they have the genomes of all people. And they also, if you have filled in their questionnaires, they know your habits, they know what you're doing, they know where you are. They can do all this incredible big analysis of complete populations. Don't be surprised when Google is coming with some medical company offering you things that you could only dream about. It's like discovering that Google is selling your habits for the politicians. It's the same. The founder of 23andMe was the former wife of one of the founders of Google. So it's there. And these devices, which is very interesting, not this one, but the one that is already in the market, was just used this year to complement and correct the default genome that is out there of human. Because you may think that the human genome was done, but the human genome is still a draft. It means it's not perfect. Why? Because there are very big areas in the areas of the chromosome that are just repeats. As Anna has problems with the repeats that you cannot put together, well, the same is still with the human. A lot of areas, you don't know where to put them because they look the same and they're in tandem. Many of these areas were still not perfect. So this year, using this little device, because it reads lengths of 50,000 base pairs, they have now corrected the human genome with a USB size thing, which was not possible to do since 2000. Tells you a lot about the potentials. We have some issues. Most people here says, wow, we jump into bioinformatics. But bioinformatics is still complex. It's a lot of tools, things that are not working together. It's databases that you don't know the name. Databases are coming and going. We have had a lot of EU projects where we created beautiful tools. The money is gone after 4 years. Everything is gone because no one can maintain. There is no program for doing that. So you don't want to have, when you need a car, to get this. It's the same for you when you want to do some bioinformatics. You don't want this. You want, of course, this. But things are that you are going to have all these wonderful devices, but you need to understand how to put things in and how to get them out. How are we going to solve all that? Because you need to work in the same way that you work with phones. You don't need to know everything. You need to use it. Because the cleverness of your work is understanding a problem, doing the analysis, and then getting solutions. So what we need in the future is artificial intelligence systems that, together with bioinformatics, makes all these tools to be and work as the iPhones in the future. So this is what bioinformatics as a research subject needs to engage in the coming years to come out with all these products. And with that, I have 5 minutes left for questions. So thank you very much for listening.